welcome to lesson 8.5. In earlier lessons, we learned about finding the center of the data, more or less. We calculated the mean or the median. Sometimes we looked at the mode, what happened most often. Today, what we're going to be looking at is how much the data varies. In other words, measures of variability. Now, the range was a measure of variability, right? It said how far apart the data was spread. This is going to go a little bit further with that idea. Well, there was a whole lot of definitions on there under vocabulary. You can turn the page and you should see part 1 that says find the mean absolute deviation to describe variability. So let's break this down. You know what mean is, right? Mean is the average. Add them up, divide by the number of scores. Absolute, we did absolute value in the past. That's how far a number is from 0. In other words, we don't care if it's above or below. We just want to know how far away from something it is. And deviation is to be different, right? To deviate from is to be different from. And then variability is the amount of change. Okay, how variable something is how much it changes. For instance, you might say, what's the weather like here in South Glens Falls? And you might say, well, it varies from day to day. Now, because mean absolute deviation is a mouthful, we abbreviate it with MAD or MAD. So here we go. We've got some math quiz scores from Anne. She's got an 82 and 99. Awesome. 76, 73, well, 92, 90, 88, 88. Those are all respectable. We want to know like how much her test grades vary, how much they change. Are they kind of close to each other, or are they really all over the place? So there's a process here. First, we're going to calculate the mean of the data set. Then we're going to find out how far away from the mean each of those test scores are. And then we're going to find the mean of those differences. It's easier to show you. Let's take a look. Step 1, calculate the mean. No problem. Going to add them all up and divide by the number of scores. And so the mean of all that data is 86. Next, I'm going to find what's called the absolute deviation from the mean. So the mean was 86. So I want to know how far up away from 86 each of these test scores were. So 73, that's 13 percentage points away from the mean. 86% is the mean. I took away 73. I found the difference, and that's a 13. Now it's below the mean, but I don't care. I'm just putting, I'm not saying negative or positive here. For 76, I just need to do 86 minus 76. In that case, I get 10. And I could do that for all these values here, all the way down until I get them all done. Okay, so those are how far away from the mean each of her test scores were. The last step is to find the mean of the absolute deviation. So I'm going to find the mean of all of these, right? I'm going to add them up, and I'm going to divide by the number of scores. So on average, each test score is 7 7/7500% away from the mean. Okay, that's how they are spread out. The larger that number, the more spread out the scores are. The smaller that number, the tighter the scores are, or the closer they are to each other. Here's one for you to try. Anne's vocab quiz scores are 75, 81, and 90. The mean is 82. They gave that to you. We want to know the mean absolute deviation. Okay, there's only 3 numbers there, so it's not too bad, but yeah, find the deviations from the mean, and then find the mean of those deviations, and we'll look at it together. All right, part 2, we're going to find what's called the interquartile range. Okay, so we need our quartiles to find the range of the inner quartiles, and let's take a look at that. I think it'll make more sense once we do it. So here we have Anne's science quiz scores. We have it on a nice dot plot here. She got 178. She got 79 3 different times. She got an 80. She got an 81. She got 82 twice, and she got an 84. And so we want to make this into a box plot. And to do that, I'm going to need to list out the scores in order from least to greatest. And there they are. And then I got to find the middle of the data, or the median. And there it is. And now I need to find the middle of the lower half, which is right there. Looks like it's 79. And I need the middle of the upper. There it is. Looks like it's 82. It's what's between 82 and 82? Well, it's 82. The minimum is 78, and the maximum is 84. And now I have all the 5 data points I need to do a box plot. So let's see, my minimum is 78, so I'll put a dot there. Got a 79 for my first quartile. Got an 80 for my second quartile. Got an 82 for my third quartile, and then the end goes to 84. Draw my box around the inter 2 quartiles, and there are my outer ones. And so the IQR, the interquartile range, is going to be the third quartile minus the first quartile. In other words, it's going to be this box right here. So it's 82 minus 79, which is 3. That's the IQR, the interquartile range. Now again, the bigger that spread, the more far apart her data points are. If that number is really small, her data points are pretty close to each other. The way we would kind of phrase that, and I should have been using this language earlier, is with a small IQR, we have low variability, right? It's not changing by much. With a high IQR, we have high variability. Now let's look at health class. There's a dot plot. Go ahead and figure out the IQR of those scores and give us a feel whether she has high or low variability. We want to talk about whether data sets have high or low variability, or whether they're spread out a lot or not. I have Jonah, who recorded the points his team scored during basketball games. The mean number of points scored was 42, right? And the mean absolute deviation, in other words, the average amount, the mean amount that their basketball scores were different than the mean, was 4 4/10. So I did 4 4/10 here. That's 46 4/10, and if I subtracted it, on average, it looks like we're between 37 6/10 and 46 4/10. The question is there a lot of variability here, or how would you describe it? I would describe it as, on average, they're scoring between 37 6/10 and 46 4/10 points. The book is calling that a lot of variability. Okay, so we'll go with that. Here's another way to look at it. Jonah's team scored 36, 37, 38, 38, 41, 46, so on and so forth points in their last 9 games. They want you to find the IQR and range of the points they scored in their last 9 games and figure out, are these good measures for describing the points scored? First thing I'm going to do is put them in order. And then I'm going to find my 5 data points that will allow me to do a box plot and find the different quartiles. And the IQR, we could put it on a box plot, but it's basically the third quartile, right here, minus the first quartile. The IQR is 47. Take away 37 5/10, which is 9 5/10. The range is the maximum minus the minimum, and that is 12. So looking at this, what does that mean? Well, the entire spread of the range is 12. The IQR is almost the same thing. So that means everything's kind of tight together, right? All the data is pretty close to that interquartile range, or middle 50%. All right, here's some straight up practice. Davita works at a shoe store, and she measures the feet of 9 customers, found their shoe sizes. We want to find the mean of that data. We want to find the absolute deviations from the mean. Then we want to find the mean absolute deviation, the MAD. And then finally, we want to find the range and interquartile range of that data. Give it a shot. We'll talk about it in class.